Okay, so our speaker for today is a Filipino civil engineer with 6 years of relevant experience in both structural engineering evaluation, investigation, design, and construction for both steel and concrete structures. He gained experience in different types of structural system like buildings and non-building structures, warehouses and foundation design using various type of structural software as per the project requirements. He is currently pursuing his graduate degree in civil engineering at De La Salle University, Manila. So our speaker for today will be Engineer Mark Espino.
Good day, everyone. I am Engineer Mark, your technical support engineer from Midas IT Philippines, and today I will be discussing in this webinar the structural evaluation and retrofit design in Midas Gen, and I will also include in the latter part the Midas Design Plus. So for a brief introduction of Midas Gen, so we call it actually a one-stop solution for building and general structure. So why? Because it has these different capabilities. So you can design your buildings, your plant structures, spatial structures, as well as the specialty structures. We also have these advanced features that you can actually found only in Midas Gen. So some of which are the construction stage analysis, post-tension analysis, heat of hydration, and the FEM analysis. So for the GUI of Midas Gen, this is actually what you can see if you open the software or the Midas Gen software. So you can see the ribbon menu, the toolbars, the task pane, the table windows, status bar, context menu, command line, message window. So this command line and message window is actually same with the CAD software that we are familiar with. So it is very simple to understand and to use this message window and the command line. So we also have this works tree. So this work tree actually show us the information in our structure. So for the data gathering procedure or the phase one of our discussion for today, so first, why do we need to conduct a structural or seismic evaluation? So first, seismic hazard has changed in some location. The design requirements have changed. The use of building has changed. So for the seismic hazard has changed in some location. So for example, throughout this year, we only knew that in this location, uh, it only produced this kind of magnitude in earthquake. So but on the later part or the next year or the following year, we have discovered, based on the scientists, they have discovered that there are fault lines near in this area that are actually new. So we also have the use of the building has changed. So for example of this is that, for example, we design an office building and soon or later, the building has changed into a mall. So something like that. So what is the purpose of the screening or retrofit procedure? So first, we identify buildings with potential seismic hazard. We determine if the original plan is in conformity with the latest code. As we all know, code changes throughout the years as well as the standard. So specify as built design strength of the today. So first, why do we need to conduct a structural or seismic evaluation? So first, seismic hazard has changed in some location. The design requirements have changed. The use of building has changed. So for the seismic hazard has changed in some location. So for example, throughout this year, we only knew that this in this location, uh, we only it only produced this kind of magnitude in earthquake. So, but on the later part or the next year or the following year, we have discovered, based on the scientists, they have discovered that there are fault lines near in this area that are actually new. So we also have the use of the building has changed. So for example of this is that, for example, we design an office building and soon or later, the building has changed into a mall. So something like that. So what is the purpose of the screening or retrofit procedure? So first, we identify buildings with potential seismic hazard. We determine if the original plan is in conformity with the latest code. As we all know, code changes throughout the years as well as the standard. So specify as-built design strength of the existing structural members and analyze existing design structural integrity in resisting gravity, lateral, and seismic loads in accordance with the governing building and latest structural engineering codes. So pardon me if I did discuss ASCE 41-13, a brief introduction of this. As we all know, we already have the 41-17, but let me discuss about the 41-13. So actually, this is very hard to discuss, especially because Tier 1, Tier 2, and Tier 3 is a very vast topic. So the Tier 1, the screening procedure is not actually that easy to explain or to actually interpret. So as well as the Tier 2 and the Tier 3. But in this presentation, I make a brief summary of this following three-tiered procedure. So for the Tier 1, this is actually more on the screening procedure, meaning you will have a checklist, and that checklist you will evaluate structural and non-structural elements. So the outcome of this list will be the potential deficiencies. So after that, we have the Tier 2. So in Tier 2, in order to perform the Tier 2 deficiency-based procedure, it is necessary or it is required that you perform first the Tier 1 or the screening procedure. And after that, you will evaluate the detail of the Tier 1 deficiencies, and you may come with the evaluation and retrofit design. This may also include the mitigation of Tier 1 deficiencies by either calculation and or retrofit. So unlike Tier 2, in the Tier 3 systematic procedure, you will go directly on the full systematic analysis of entire building. So no need to do a screening procedure. So what you will do here is actually go on to the evaluation and retrofit of the structure. So next is this is actually the workflow on how you perform the evaluation process based on the ASCE 41-13. So you will have to first understand the evaluation process, select performance objective, define the building performance level, the hazard and seismicity level, and obtain, of course, the very important information in the evaluation process. So for me, this is the as-built information. So after that, after you completed this four process, the selection, defining building performance, you will now proceed with either Tier 1 or the screening procedure, or go directly on the systematic procedure. So I will not be discussing more on the tier 3, but rather I will be discussing more on the 1 and 2 tier of the ASCE 41-13. So for the performance objective, you can refer to the section 2.2 of ASCE 41-13. And this performance objective is actually have three parts. So we have the limited or reduced performance objective, the basic performance objective, so in which we have the BPOE and the BPON. So for the evaluation of existing structure or basic performance objective for existing building and the basic performance objective for new building. So last is the enhanced performance objective. So for the structural performance level, actually we have five structural performance level, but for the limitation of tier 1 and tier 2 analysis or evaluation, it is only limited to the immediate occupancy up to the life safety. So for the immediate occupancy, brief explanation of this is that in immediate occupancy, so after an earthquake or post-earthquake, the structure will be still in fully operational. Whereas in the life safety, post-earthquake damage state in which structure has damage component but retains a margin against onset of partial or total collapse. So meaning you can still go out of the building after an earthquake. So there are damage, but uh, you can safely go out on the building. So it is no longer operational unless you perform a building retrofit or more on the global or local retrofitting. So damage control is that uh, it is operational after an earthquake, but limited repair works will be done on the structure. So for the performance objective, so we have the non-structural performance objective. So we actually call it ABC. So the operational, position retention, and the life safety. So I will not be discussing more on the non-structural performance level. So for the selection of performance objective, actually, based on my research, uh, this is based on the scope. This is beyond the scope of ASCE 41-13. And also, this depends on whether it is mandatory or voluntary. So why do I mean by voluntary or mandatory? So actually, some of the, uh, for example, in the US, it is actually they have this mandate. For example, in California, there is a mandate to select the best performance objective. So we also have this based on factors such as level of safety needed, cost of the repair, business interruption, architectural or historical effects, and community effects. The selection of performance objective is discussed in FEMA 274. Application of standard with good example is in Appendix B of the 41-13. So for the performance objective, so BPOE is used for evaluation of existing buildings. So I will focus more on this uh, BPOEs since we will be discussing on the evaluation of existing structure. The structural and non-structural performance level per risk category can be found in table 2-1. So for example, you have this risk category 3 and you will perform a tier 2 analysis. So you will have to do a damage control structural performance retention for for the non-structural performance 2B. So BSE means basic safety earthquake. So for the seismic hazard level, this is actually discussed in the section 2.4 of ASCE 41-13. For existing building hazard, so BSE 1E has a return period or 20% in 50 years. The seismic event will happen at 20% in a 50 year. and for BSE 2E, 5% in 50 year. So for new design equivalent hazard, so we have this BSE 1N. So 1 or the N is actually refer to new, and the E refers to the existing. So where to obtain such data for the return period of our seismic analysis? Some codes and standards, researches, or for example in the US, they have the USGS. So geotechnical and site-specific investigation also provides the seismic hazard level. So for the level of seismicity, this is actually discussed in section 2.4 of ASCE 41-13. So for a brief of this, we have the 4 level of seismicity. So we have very low, low, moderate, and high. So this depends on the SDS and SD1 based on the data or based on the as I have said before, the geotechnical or site-specific researches and codes. So equivalent to seismic design category in ASCE 7-10, so SDCA is very low, SDCB is low, SDCC is moderate, and SDCD, E, F are high. So part of the data gathering procedure is the as-built information. This is discussed in section 3.2 of ASCE 41-13. This is actually the most important information that we should obtain if we are going to evaluate an existing structure. So obtain general information about the building. So as-built information sources includes available drawings, technical reports, and specifications, prior studies and reports. We should also have the on-site verification, typically non-destructive examination. We should also do the interviews with the building owners, maintenance staff, building admin, tenants, building managers, original architect or engineer if possible in order for us to have this as built information or sources that is very important if we are going to evaluate a existing structure. Testing of building materials components per chapter 4, 5, 6 of ASCE 41-13 may be required if necessary. So for the common building types, this is discussed in section 3.2.1 of ASCE 41-13. So we should be able to classify common building types per table 3-1 of ASCE 41-13. So this depends on the seismic force resisting system. So meaning if you have a shear wall, you have a moment frame, and also you have to, it is based on the diaphragm type. There are 25 common types of building or the 25 common building types. So we have for the wood, for the steel, the dual frame, the concrete, and so on. So for the tier 1 and tier 2 of ASCE 41-13 limitation, this is actually based and discussed on the section 3.3.1 of ASCE 41-13. This is limited in performance level. As I have said before, for the structural, you can just do immediate occupancy, damage control, and the life safety. For the non-structural, we have the B and the C. So for the limits with building type shall conform to one of the 25 common building types. So there are actually tables that shows on what is the required height of these structural elements. So limits with building height is based on the table 3-2 of ASCE 41-13. Based on level of seismicity, common building type, performance level. So this is what I'm talking. So if you have a wood frame and you have this S3 or the life safety, so for the low seismicity level, so you have no limit. So if you are doing this on immediate occupancy, you can actually do for a light frame or light wood frame for up to 4 story. So that this is how you interpret this table 3-2 limitation and the use of the tier 1 and tier 2 procedure. So for the overview of tier 1 before we proceed with the sample or our case study. So for the overview, so this is discussed in chapter 4 of ASCE 41-13 where the overall procedure is the selection of performance level, determining the seismic hazard level, determining the level of seismicity, as-built review, and on-site investigation. This is actually what I'm talking before. And we also have to classify the building, check the limitation of tier 1, check building benchmark, and perform the tier 1 analysis, select and complete applicable checklist. And of course, we have to prepare a report. So this report should show if we need to perform a tier 2 evaluation or that's it. So we are finished with tier 1. So this recommendation will show if whether we should do a tier 2 evaluation. So this is an example of the checklist for the tier 1 evaluation. So you have the building information. You also have the basic checklist. So actually you can check if it is compliant, non-compliant, not applicable, and so on. So we also have for the life safety, basic configuration, and life safety structural checklist, and so on. So for the overview of Tier 2 analysis procedure, this is actually discussed on section 5.1 of ASCE 41-13. So Tier 1 screening procedure should be done first. As I have said before, in order for you to proceed with Tier 2, you need the results or the recommendation of the Tier 1. The Tier 2 scope is limited to additional evaluation of the deficiencies found in Tier 1, whether it is non-compliant, NC, or unknown, which is U. Outcome for each Tier 1 potential deficiency shall be resolved or mitigated by Tier 2 evaluation. And does it confirm deficiency by Tier 2 evaluation? So if it confirmed or not, so we have to decide if we will propose Tier 3 systematic procedure or propose a retrofit design. So this is actually the workflow in order for you to design the evaluation using the deficiency base or the Tier 2. So if you will be doing a building analysis, so there are also a workflow in order for you to perform the analysis. You will choose what type of analysis you should do. Is it either LSP or linear static procedure or the linear dynamic procedure? And so on, checking the demands, analyzing the building first, then checking the demands, compute the capacities, compare the demand and the capacity, summarize the report, and after that, you may proceed with the retrofit design or perform Tier 3 analysis if this Tier 2 evaluation is not sufficient. So for a more detail, first is we identify the potential deficiency based on Tier 1 process and check if it is structural or non-structural. So we go with the structural, for example, and after we have gone with the structural, so we should read Appendix A item and check if the specific statement for the potential deficiency in section 5.4 and 5.5 to 5.7 is uh, needed or complied. So after that, we have to check if the tier 2 available, or is it available. So after we have done the tier 2, or check if it is available, so check if there are condition issue. If yes, so you can proceed with the analyze condition to see if it is acceptable during reduced capacities. And if it is no, you will now go to the Bayesian check, or the building analysis required. Does it require a building analysis? So if it is not required the building analysis, so you should check the diaphragm ties. This will only focus on the wall thickness, proportion, wall connection, girder flange continuity plates. So if there's no need to perform a full building analysis, so for example, you don't have a complete load path, so you need to check this portion first: the diaphragm, the ties, the girder flange, wall connection, and so on. So if it is required to perform a full building analysis, then you should do a full building analysis. So for the full building analysis, so first is you choose what type of analysis. Is it either LSP or LDP? So linear static procedure or the linear dynamic procedure, or the for the LSP equivalent static analysis, or for the LDP response spectrum or response history analysis. So after selecting based on the required criteria or the limitation, so you can now perform the analysis of the buildings, compute the demands, compute the capacity, and of course compare these demands and capacity. So after you have checked the demand and the capacity, you can now summarize the report, and if so, if the deficiency remain, you may proceed with the retrofit design or perform a tier 3 evaluation or analysis. So in performing tier 3 analysis, this actually depends on the recommendation of the evaluator of the structure. So tier 2 as built information and condition assessment. This is discussed in 5.2.2 and 5.2.3 of ASCE 41-13. So for the as built information, this may need an additional information compared to tier 1 evaluation. So meaning you have to produce a more detailed information of the as built structure. You may either conduct a destructive or non-destructive examination of the deficiency. And of course, the default material properties from chapter 8 to 12, 14, or 18, or from drawings can be also used. So for the condition assessment, review and consequence of deterioration identified in the first year, and after that, if damage identified to seismic force or SFRS element, their impact including reduction on capacity shall be reviewed and documented. So acceptance criteria and analysis method for tier 2. This is discussed in 5.2.4 to 5.2.5 of ASCE 41-13. So for a brief of this, you can perform either two types of analysis, which is the linear static procedure or the equivalent static analysis, and the last is the linear dynamic procedure or LDP, which is composed of response spectrum method or the response history method. Extent of the structural modeling shall be adequate to provide forces for elements subject to tier 2. So in order to model your structure, so you need a complete set of information or the full building information which may require you to model the whole structural building. So for the acceptance criteria in accordance to section 7.5.2 and the component capacities per chapter 8 to 12 and 14 should be satisfied. So for the evaluation procedure of Tier 2, this discussed in section 5.3 to 5.7 of ASCE 41-13, and the evaluation procedure for each deficiency is stated in their respective section. So for example, if you are checking or evaluating the connection, so you should check on the section 5.7, or for the SFRS or the seismic force resisting system, so you can check on the section 5.5. So these are some of the check that you should do in the Tier 2 evaluation. So what is the purpose of retrofit using the Tier 2? So performed Tier 2 evaluation did not mitigate Tier 1 deficiency. So the purpose of this retrofit may mitigate Tier 1 deficiency. The resulting retrofitted building shall comply with Tier 1 screening and the Tier 2 deficiency base. So for the ASCE 41-13, it has these guidelines for ranking of retrofit measure. So you can refer to table C51 through C519 based on the different building types. So ranking is in order of most critical, intermediate, and critical. So next is that we go to the information of our structure. Suppose you are checking the structure, so you should do a visual inspection. So you may also draw the different measurements. So for example, there's no drawings available, so you have to do a manual, or you have to go first into the site and check the dimension, the length, the building plan, or the footprint of the structure in order to detail, or this is actually based on the requirement that you need in order to come with the Tier 1 and Tier 2 evaluation. So you will use the different design codes. So for example, for the beams and the columns, you have this design strength based on the testing of the materials. So since you do not have information on the drawings, or you don't have the drawings, so these are some of the following that you have to check. So if there are cracks in the walls, so for the non-structural, so for the beams, you should check or document the different cracks that you have seen into the existing structure, as well as in the column. So this is very important, these following images, especially when you are doing the visual inspection first, or the Tier 1 analysis procedure. So you will also have to conduct different tests, the rebound hammer and rebar scanning. So for the structural analysis and evaluation, so this comes here, the Midas Gen. So let me go to the Midas Gen software. So this is actually the building, or your building structure. So we have a 6-story building. Let me show you the number of floors. So 6-story with roof deck. So for the structure type, we are modeling a 3D structure, and the self-weight into masses will be converted to XY direction only. So it is important to have a Z direction, especially if you have a rotating or a generator installed into your structure. So one thing that we should notice, so I will not be detailing most on the on how to model this structure. So since this procedure is very tedious, so I have initially prepared a model for this case study. So next is that we check for the material properties. So for example, this is the material properties based on the test. So the rebound hammer or the concrete test that you have done. So for the beams, you also have the columns. So we also have to add the stiffness scale factor. Basically, this is somehow similar on how you model your structure. So you add the different parameters or the different required criteria on the modeling. So you will also have the different loadings. So for example, let me show you the beam load, and you also have the floor load. So let us check for the load table. So let me undisplay this. So you will also have to check for the load table. So for example, I'm just showing you here the different parameters that I have included in the model. So you have the different load types. So for the rooms, corridors, and roof deck, so you have these different dead loads and live load applied. You also have the floor load, so whether it is a two-way or one-way distribution. So let me just close this. So aside from the gravity load, we also have these lateral loads applied. As I have said before, this is actually almost the same as when you model your structure. So you have the story shear, so you can check the graph. So the parameters, this is actually based on the previous slide that I have shown you. You can also make the calc sheets, a detailed calculation of this. So same with the seismic load. So for the seismic load, so you have these parameters based on the, for example, based on the plan or based on the test or the or on the specific location. So if you don't have the data. So I have also included the dynamic load. So for the response spectrum function, I consider the UBC 1997. So this UBC 1997. So here in Midas, you can easily plot the response spectra here in Midas Gen. So we also have the RS load case. So we have for the major axis, the auto search of the excitation angle is check on. So you also have the for the orthogonal axis or in the 90-degree direction. So after adding those parameters, I can just simply perform an analysis. For example, so after performing an analysis, let us check some of the results, like for example, the vibration mode shapes. So you can see the period of the structure, the modal participation. So it start with the third degrees, the rotation of the building start to rotate on the third degree or the third mode, sorry. So let me show you the animation first. Legend. So let us check mode 1. Let us animate. So for the mode 1, so it is going on the Y direction. So for the mode 2, X direction. And as I have said, it will rotate on the third mode. So after checking the analysis, we also have to provide the design code. So for example, you have designed this building into the uh, old code, so you need to select the required design code. So since we are using, or the NSCP 2015 is merely based on the ACI 318-14, so you can check on the requirements based on the design code of ACI 318-14. So aside from adding the design code that we'll be using into the evaluation, so you should also modify the concrete material. So this concrete material is based from tests. So for example, based on the test results found, so we have the FC prime of concrete, which is 18,437 kilonewton per meter squared, and for the column is 21,249. So after we have modified the concrete materials based on the test results, so what's next that we should do is modify the rebar area. So this rebar area will be based by either rebar scanning, or if you have a plan, so you must include the rebar area uh, which is specified on the plan. So you will need to add, so for example, I will be considering, for example, element 1. So this element 1, so you can modify the rebar area for the top. So you can provide 3. So if you have 2 based on the plan, so you can modify this. Or in the center, so and so on. So you also need to provide the stirrups as well. So this information is actually very important, especially when you are evaluating the structure. So you need to uh, model actually almost similar into the actual condition, or into the actual. So after you have modified your beam, you can also modify the column rebar data. So same with the beam. So you will provide the number of rebars, the diameter of bars, the rows, and also the tie spiral. So we have two shearing area, number 3, and the spaces. So most of this again is based from the results, or based on the plan. So after we have modified the plan, or added the rebar area based on the actual condition, so we also have to add the load combination. So this load combination should satisfy for the concrete. So you can add based on the preferred code, ACI 318-14, the scale up factor. Actually, I scale this. So I initially perform a static analysis, and then perform the response spectrum, and compare with the dynamic Bayesian to the static Bayesian, and provide a 90% uh, factor for a regular structure. So I come up with those response spectrum factor, scale up factor. So after doing that, we can now perform the checking. So first we can check, again, we can perform analysis and concrete beam checking. So as you can see here, initially, for the beam checking based on the rebar that we have inputted, so most of the primary beams or girders have failed in the negative and positive moment. And for the stair beam, so we have no fail elements. So as you can see, you have the different ratios shown. For example, for the positive moment and the negative moment of the beam. So most of these have failed. So there's one member that is actually passed on the midsection. So we also have the passed member. So if you would like to connect, an example of this is if you would like to connect which one has passed. So first I can check on the connect model to view, and then I select all, which is okay. And it shows you which are the element has passed. So, and of course, the reverse of it, the failed element is mostly the primary members. So let me check one and show you the graphic. So if you are not yet familiar with Midas, this is actually what you can see if you view the graphical result of Midas. So you can see the details, the capacity ratio for the bending and the shear. For example, if this is the beams, you can also check on the detail. So in the detailed result, it's like a reviewer, or actually because most of the formula based on the code is present here. So you can easily check. It is not a black box that you see a failed member or a past member. You can actually verify the result. So same with the column. So you can check all of the members that failed. So let me show one. So for the graphical result, so same with the beam, it shows you the relevant information. So if I have chosen the detail, it will also show the detailed analysis or result. So if we want to suppose this is the result of our investigation or analysis. So after we have done that, so for example, we recommend the retrofit in the structure. So let me open Midas Design Plus. So for example, this is Midas Design Plus. And what I will do here is go to the Reinforce tab. And actually, you can perform a retrofitting for the columns, the beams, and the slab. So let me give you an example for the beam. So for the beam, what I will do here first is to link Midas Gen, the model that we are discussing. So after we have linked the Midas Gen into the Design Plus, we can check for the option of the link. So I can link it by member. So apply and OK. So let me just check the different parameters. So to give you an example on how we can retrofit here in Midas Design Plus, so for example, I want to retrofit a specific beam that has failed. So after we have connected Midas Gen to Design Plus, going to this portion or the member, so I can select, for example, one member of the frame. So for example, I want to retrofit this failed member or this girder. So going back, as you can see, member 1 has been selected. And then I can simply import. So in detail, it is showing the eye section or the ends start, the mid and the end section of the beam. So an example of this, for example, we have a 125 millimeter thick of slab. So the width, this is one section. So you can actually, most of the information based on the initial analysis is being carried out here in Midas Design Plus. So if you will be doing the retrofitting design here in Midas Design Plus, so you can do so. So for the width, so we have 300. For the height, we have 325. And what if I have, for example, a user-defined materials? So let me say I have a strength of, let's say, 621, and the modulus, elastic modulus is, for example, 37,000. So we have a strain of 0.01. So this actually depend on the material or the properties of the commercially available retrofitting material. For example, the FRP or CFRP. So we have the strain. So for the thickness, let's say we have 1.02 millimeter thickness. And let me say I will use the material user defined. So this, for example, this is based on the commercially available material. So I will have to provide the exposure condition, the reinforcement properties, the width for the shear reinforcement. Let's say we have a 50 millimeter strip, two side banded. So this side and this side. And after that, you can check. So let us check for the result. So for this, you can see the different information, the inputs, the loadings, and of course, if you check, there are still a failed member after we have performed the retrofitting. You can either choose the design, so it will automatically select which or the properties, or I mean the required reinforcing material or the FRP required in order to cope with this capacity or the demand. So you will have to iterate this input of yours in order to satisfy the condition. So again, we can also do this into our column. So for example, let me select one column. So let me select this column type, this one. And after that, I can now easily import. And of course, after I have imported the material, so again, I will provide the necessary information. Let's say we have a 621 MPa, only 37,000, elastic modulus 0.01, and the thickness of the reinforcing element. So let's say I will use a user define, and the number of pieces for this required. So after that, after filling up the necessary information for the retrofitting design here in Design Plus, you can now check. And again, you can check if there are still failed members. So as you can see, there are still failed member. So what we can do is perform a design. So again, if the design is not yet capable, so you need to either increase the thickness, or you will have to iterate the input properties of yours in order to satisfy the required demand on the specific element. So these are an example on how you will perform retrofitting design here in Midas Design Plus. So going back to the presentation, So for the conclusion and the recommendation, so based on the analysis and investigation of the whole structure, most of the elements have failed in flexure and or shear. So the retrofitting analysis performed is much needed for the primary members in order to resist the loads acting on the structure. Since local elements are checked and local members are retrofitted, it is much better to furtherly check the overall performance of the structure. So what I have shown you here in this presentation is that we have conducted a local retrofitting. There is actually a global retrofitting where you will have to install a BRB or either install a shear wall in order to retrofit the existing structure. So those are some example of retrofitting based on the global retrofitting. There are different procedures. This is just a brief example on how you can perform analysis, evaluation, and retrofit basically using Midas Gen and Design Plus. So for the end note, all the things presented in this session is for reference only and to give a basic background on how to perform a structural investigation and evaluation. Further checking and evaluation of the structure should be done carefully. It is still the designer's responsibility on how to properly interpret the results gathered from test, reference, and from observation. So again, that will be all, and I hope to see you again on the following webinars that we will still be conducting. So you can email us at phinquiry@midasit.com or ph or philippines@midasit.com if you have any further questions or queries regarding this webinar or different queries if you want to get your own Midas software. So thank you very much and God bless you all.
Thank you so much, Sir Mark, for that wonderful presentation. Um, and then now we will be proceeding to the promotions. We will be going back to Sir Michael for the explanation of the promotions.
Hello, hello, good morning, everyone. I hope everyone can hear me. Um, so thank you very much once again. Thank you very much, Sir Mark Espino, for that very elaborative and detailed presentation on the retrofitting design of Midas Gen and structural evaluation. So moving forward with our presentation, I'd like to go over and briefly discuss our current year-end 20% discount for Midas Gen. So for the engineers who are very much interested in getting the program, I think this is a very good offer for you to get to take advantage of to get Midas Gen license, perpetual license. So aside from the 20% discount, we've been also trying to consider the fact that there has been a change in all of our lifestyle and maybe our cash flow has been affected. So we've been trying to offer the Midas Gen program in longer payment plans. So to get you may also opt to get Midas Gen, the discounted price of Midas Gen in 6 months payment. Um, you will only be paying 46,233.60 for 6 months. This comes with zero interest, 0% interest. This is already the Midas Gen perpetual license. Ibig sabihin, you can use the program for the rest of time. This is already inclusive of the 12% tax and MODS for 1 year. Our MODS is our Midas On Demand service, which includes the technical support, updates of the program for 1 whole year will be provided to you. And also the MODS module including Midas Design Plus and DShop. Yeah, of course, this price is already inclusive of the 20% discount, and you can choose to pay your Midas Gen program through check, credit card, or wire transfer, which is you can choose which one is more convenient for you. And then also for those engineers who find this figure high, kasi of course we have to understand that the December will be a very hard for us to a month hard for us to release this amount. We are also offering for the first time in our history, a 12-month payment plan for our engineers. You will only be paying 29,973 for 12 months. Still perpetual license, inclusive of 12% tax and MODS for 1 year. This is in partnership with Security Bank through our personal loan. So we will be processing the personal loan, but the I'm sorry. Okay, I'm sorry about that. Going back, 29,973 for 12 months, and this is in partnership with Security Bank. We might need to submit some documents for us to be able to do the personal loan, but this is already a really good price considering the 20% discount and 12 months payment plan. Um, if you are very much interested in getting the program, you can choose to contact me in my email, Philippines at midasit.com. My contact number is also in the email invitation and is present everywhere from the text messages and also from the postings that we do. You can always contact me for that. And then before we end this webinar, we'd like to study more about the 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 market here in the Philippines. As I mentioned, we are here to listen. We have prepared three questions for Pulse. I hope everyone, all our attendees, all 173 attendees in today's webinar can join this poll. All you have to do is just answer. So first question would be, um, how would you rate your urge to want to use Midas Gen in your projects? Very interested, thinking about it. Maybe not in the soonest possible time. Not at all interested. I hope everyone can join. Will be We'll have 15 seconds more to answer. I hope everyone can answer so that this will help us gather this will help us in planning more of our activities, promotion, and technical activities here in the Philippines. Okay. 5 seconds left. We'll be extending for 30 seconds more kasi 55% have only voted. I hope everyone more and more can still vote. Oh, okay. I think that's enough. Next, we'll try to. The next question will be, what is your consideration? What are the considerations you are taking in possibly getting Midas Gen? You can choose multiple answer for this question. So, ano po yung mga consideration that the factors that you are considering in getting this program? Is it